All right, let's talk a little bit about the issues that we have with the waterfall approach, or the classic criticisms of it as well. Um, when we have changes that are required, because there almost always are changes required, that's going to result in delays, and so we need change control to say we're not allowed to have changes. So we're in a real catch-22 here. We What are we supposed to do? Like, invariably, customers realize, oh, that's not quite right, or we misunderstood, or as we develop it, we have a better understanding. So changes seem to be inevitable, but they're going to result in delays, and so therefore we refuse to allow any changes. So it's a tough situation to be in. That really speaks to that what we really need, that one of our biggest problems is that I suspect that often the planning and specification actually truly are inadequate. It may not be possible on real projects to ever have an adequate specification. Or it might be outside of the bounds of what is reasonable to expect. Maybe we need to expect that we are going to do this, but it is going to take a lot longer than we planned. We're going to need to do maybe resets. Maybe we're going to need to replan, plan on a more frequent basis, be adapt to change. Oh, before you know it, we've invented Agile and Scrum. Okay, because the process has little flexibility to adapt to changes. And if in many ways I do think you can look at a lot of Scrum as better engineering practices combined with a system that allows us to function with changes. We're not throwing away planning in Scrum. There's a lot of planning in Scrum. There's a lot of design work. It's just that we work in chunks such that we can then change focus and direction based upon the changing needs that we realize and the client needs. And we have evidence, by the way, that a good specification is great. We give homework assignments to students all the time. And after enough refinement, because often the first version of the homework assignment is not good enough, after enough refinement, students, every detail that they need to know to get that work done is in that specification for writing that program. I think we did a pretty good job on the Spell Manager specification in MSci 245. There were a few issues and a few questions that people had, but largely people were able to build out the Spell Manager application and have the behavior as we expected it to be. And if you think about the comparison, look at all that you were able to build in 245 in what was a relatively short amount of time, compared to about what you've been able to build so far in 342, and you might be a little frustrated. But the big difference is you were given a complete specification for exactly the behavior that needs to be. Here in 342, you don't know what it all is. You're needing to figure it out and design it from scratch and learn from the customer and your own interaction in your development work. Design is hard work, and that hard work takes more time. Basically, when we wrote the specification at that level of detail, we had already done a large amount of the work on a typical project for you. So when you can't have this adjustment in place, you're going to often be late then on your projects, or you're going to be on time, but it's going to be low quality, filled with bugs. But often we demand that things get done at high quality by that deadline, but because we had to adapt to these changes, you end up in these death marches, just these huge slogs of working late and the employer bringing in food and working on the weekends and things like that. And this is not a pleasant environment. It's not sustainable for a team. And so teams don't like this. and hence a move to agile, where the teams can be healthier and to actually incorporate the more modern engineering practices. So yeah, too often it's out of date engineering practices. Traditionally, this process was associated with holding a separate quality assurance team. That's not a recommended approach anymore, really. If you're going to have people in software testing, their job really is to be helping build better frameworks, improve the automation on the project, be helping developers learn how to test their software better, and so on. Often you'd have inadequate review and so forth and so on. I also would say that I think one of the problems with the traditional waterfall is it's easier to have bad values and poor teamwork because it's not taught. Those values are not often taught as part of that development process. Whereas when we go to Agile, we're much bigger on, we have to focus on these issues that we've learned from the past are a problem, and we're incorporating them into the overall process so that we have better values applied to the system so that we actually, in better teamwork. So for an example, I think Waterfall likes to stick too much and allows too much maybe of a command and control hierarchy, where the boss tells people to do stuff. The boss assigns tasks to people. People don't self-assign themselves the work. They don't sign up for it. They don't commit to it. They're just told what to do. The boss goes often, won't actually ask you how long it's going to take. It tells you it should be done in this amount of time. Bob says it'll get done then. Likewise, even if they do ask for your estimate, they're probably not going to trust it. Oh, you say it's 2 days. It sounds like you're padding that estimate so you can sit around and not work hard. I'm going to tell you can get it done in a day. There are important values that we need for these processes to work. Whether it's agile, whether it's waterfall, you're absolutely going to need a set of proper values. And so Stellman and Green, here Stellman and Green are talking about the values that they see necessary for a software process. And the process they're largely outlining is a waterfall process. These values are really similar to what we know we need in Agile and Scrum. But I just think that in Waterfall, it's too easy to fall away from these values. So what they believe is most important is transparency. Okay, and the idea here is, that you're always dealing with truth all the time, as they say. So we're not having to basically lie to each other. A lot of this is about time and estimates and status of the project and so forth and so on. A big thing here is that we really must trust the people and then hold them to their estimates. So the deal is, you tell me how long it's going to take, but you darn well make sure it's going to be done in that amount of time. You don't tell them how long. You need to trust that that's an experienced professional. If they tell you it's going to take 2 days, it's going to take 2 days. Don't second guess it. If they never get it done on time, they haven't earned the right to be estimating things. They're always wrong. If they're always hitting their estimates and they seem to be getting as much work done as other people, that's where you want to be. Likewise, this goes hand in hand. You've got to have trust the team to make decisions. And we've talked about this with humility, respect, and trust. And it's interesting, it shows up again here in Stellman and Green's. You know, you need to trust them to make good decisions, but be sure, you know, you need to use good engineering practices to make sure that these decisions are actually high quality. So we need those code reviews and those checks on stuff. And as well, you know, you need basically equal time to testing. All right. You need to give it its proper due. It needs to be incorporated into the process as much as possible. So these are things that what I feel, and as well, Stillman and Green say you need to have them, but I kind of get the feeling that Waterfall makes it easier for these to disappear. I feel that they're more embedded into the actual process of Scrum and the other agile processes. And that might just simply be based upon the fact that we've learned over the years about how to do things. There's a whole bunch of other stuff that we can talk about that go hand in hand with the waterfall approach. And things that are traditionally taught to you as you're doing project management of this style. I may have mentioned this before earlier in the term, but there is a rule of thirds. And this rule is basically that you're going to spend a third of your time planning, a third of your time on your development work, and a third of your time in testing. And as I may have mentioned before, what I think is most important about this is remembering this. This is even in the case of our agile sprints for Scrum, is look, you got to spend your time planning. And we do planning in Scrum with both our sprint planning, our daily stand-ups, all right, and also it blends into our design work that we do before we actually get into the coding. So we've got to remember that when we look at and we estimate our stories and their story point sizes, that it's not just the time that you spend coding, by the way. It's the overall process that you do. And this is another reason why story points work so well, is as the team develops better testing, better review of their work, they do all these things, their estimates naturally and their velocity naturally adapts. So, okay, that's that same, that even so as a team, that's that same sort of complexity of a story. They don't have to say, now we've learned that we do better code reviews and we do better testing. It's going to take longer. What will naturally just happen is their velocity will drop for those same story points, and the team will learn, this is actually how many stories that we can get done in a sprint at our proper high level of quality. Now, a lot of people believe actually you'll probably find that the velocity doesn't change that much because you'll spend far less time dealing with bugs introduced into the system and so forth and so on as you improve your engineering practice. So that's one thing that you're often taught when trying to make that project schedule. Remember, things are approximately how long things are going to take, a third, and a third. You'll often see some sort of iron triangle or some other name or project triangle. The one I learned, there's all sorts of varieties of it out there. These are showing that these parts are interconnected. Your resources and or in software, this is largely your resources, your primary resource in software is people. You're not really spending lots of money on equipment and other things, but it's people you need. How long do I have to get the project done? And then what's the scope? How much work is going to be done, but also at what level of quality? All right. Now, let's assume that quality must be good. So we're not going to manipulate and play around with quality. All right. So let's cross that off to start with. You really shouldn't be saying let's get the project out and have more bugs. Um, Classically, we say that adding more people to an ongoing project, so you could add them up front, but an ongoing project will not help. And the reason we talk about this triangle, is because often in the waterfall approach, you find out we're not going to be done on time. Gosh darn it. So what are we supposed to do? So you come back to your triangle. Oh, we're going to cut quality. No, we're not going to cut quality. Can we add people to the team? So adding people to an on project will not help. It usually results in a slowdown until they're up to speed. And it might be too late then. So there's all sorts of work to incorporate people. So the traditional project management guidance is adding people to a project isn't going to work. But there is debate about whether that's true or not. Some people are trying to figure that out. But traditionally, we say you can't really add people to a team as you're working on stuff. So you're locked on that. Then business will almost always tell you, you can't change the deadline. It's got to be ready by this, because marketing depends upon that. We've got to get it out to the shows. We've got to get it, and time to market is so critical. So time's not often something that's left to negotiate once you're running out of time. So you're left with scope. And so you end up learning very quickly on as a project manager that scope is what you often are negotiating. What are we not going to build? We handle that naturally in Scrum. We prioritize things, and we're constantly updating the priority of these stories. So what gets built is what can get built in the given amount of time. You do the same thing in Waterfall once you realize, yep, we can't get it all done by your deadline. Can't get it done. No, so we can't get it done. So what aren't we going to do? What is that the same thing, the equivalent of? Well, please prioritize the features that you really want. What's most important to you? And then we'll get that done in the time that's remaining. So it's the same sort of thing, but it's rather than being upfront, it's usually an extremely uncomfortable conversation. And it might have to happen frequently. Oh, let's talk about what else are we going to cut? What else are we going to cut? Instead, it's just always apparent with Scrum. This is, yep, we can show you what we think we're going to get done by this date by estimating things out. It's not a promise, but you can see, we can estimate it. All right. Another big project management tool often used, especially for Waterfall, is the idea of make sure that you make milestones in the project. So these are checkpoints in the project with very firm criteria to know whether you've met it or not. Met the milestone or not. And so you're taught as a project manager not to flex and bend upon this, because you need to be reporting to upper management. Yes, we have made milestone 1. We have made whatever the name you gave those milestones, because the upper management has been told what those milestones have been told, what those criteria are, and once you actually have hit them, yep, we know that we're actually there, and we've reached that status of the project. Another really important tool is to always build in buffer. It's always needed. So this is additional time. So you project out it's going to take this long, but you stick in some extra buffer based upon the fact that you know that there's a ton of uncertainty. It's always needed on these projects. Usually the recommendation is about 20%. So if you think the project was going to take, 5 months, you tack on a whole additional month and say it's actually going to take 6 months, and you carefully monitor how much of your buffer are you eating up. And it's once you realize you're running out of buffer that's when you go and you negotiate back to the scope and other sorts of things. We have all this uncertainty. We've tried to do all this planning up front. We know that there's our issues. They're going to change things, cause delays, so we need to keep that in mind. And finally, probably the last big thing that you're taught is a depressing thing, which is you're going to need to build the thing twice. And this comes from the Mythical Man Month. There's a whole bunch of classic advice in this book by Fred Brooks. This was written, he worked at IBM, this is 1975. Some of it's not believed anymore, but he talks a lot about the issues and the delays in software projects, and of course all of it was done with a waterfall approach, and they were having all these sorts of problems back then as well. And so he basically, the quote is, something is basically plan to throw one away. And he's like, you need to plan that you're going to build the software and it's not going to be the right thing, and you're going to have to build another version of it before you get to the right thing. So when you do your overall planning, plan that you got to have a version that you throw away initially, because it's going to happen no matter what. The basic idea is the first version is always wrong. I always heard early on, for example, Microsoft. Watch out for Microsoft. Their first version, not so good. Second one, pretty good. Ooh, the third version, they'll nail it, and it'll take and dominate the entire market. A version of this that is nice is to do a prototype. And then we talked about that in the design specifications. So do a prototype and throw it away. Basically, if you're going to have to throw it away, make it low cost. Lower your cost to learn from this, rather than make it high cost, rather than build the whole system and have to throw it away. Make a prototype, learn from it, and then throw it away. All right, that largely covers everything I can think of to talk about for the waterfall method of software development. Thank you.